On day 48, students brainstormed ideas for products that minimize or maximize thermal energy transfer for people in extreme climates to use. The following day, students joined groups and shared their ideas before deciding on one idea to pursue further. Next, they identified criteria and constraints for their design. Now, on day 51, students will start to actually design a prototype of their product. In doing so, students are continuing to engage with the design cycle or design process. First, students define the problem in terms of criteria, the requirements for their products, and constraints, the limitations. They also gathered inspiration from existing ideas and data. This included the experiments they designed and performed in Task 4, as well as other external research they may have done into similar or existing products. Now, they will continue to design their products by creating a drawing for a prototype, then actually building and testing it to see if it works. A prototype is basically a working model. It should perform the intended function of the product, but it doesn't have to look as finished as something that might be sold in a store, say. It's like a working first draft, accomplishing its goal, but most likely it will have room for improvement. It's important to remind students that they will really be expected to build a prototype of their product. This will help ensure that they focus on possible products and not magical or unrealistic products. One way to help them stay grounded is to have them list materials they have available to use before they start drawing a plan. What materials do they already have available in their own homes? Or if you're in person, what materials can you provide students with at school? This list might help students recognize that materials can really mean just about anything. Plastic wrap, aluminum foil, cardboard, these are often available at home, with permission of course. It may help to show students this list and have them brainstorm things to add to it. Remind students that if they use tools like a hot glue gun, they must do so with adult permission and supervision. In order to actually create a drawing of their prototype, students have a few options. First, they can create a drawing on paper with pen or pencil and a ruler. This is a good option for especially those students who have internet or technology issues, but may also be preferred by students who are just not as tech savvy. Otherwise, students have digital options. They can simply use Google Drawing, as they have before in previous assignments, or another app on their device that they've used before. Even Google Slides or PowerPoint have enough drawing options and tools for students to make a good drawing diagram of their prototype design. Another great option is TinkerCad. It's a free online site for creating technical drawings and provides great graphics and advanced options for students to use. CAD, C-A-D, is an acronym that stands for Computer-Aided Design. There are many expensive CAD apps and software out there for architects and engineers, but TinkerCad was created with students and other amateurs in mind. It allows you to easily add everyday objects to drawings and combine custom shapes in order to create a three-dimensional drawing of a product. Let's take a look at how it works. If you don't already have an account, it's easy to create one by simply logging in with your Google Gmail account. If you don't have one of those, you can create a TinkerCad account for free. Once you have your account, create a new project workspace by clicking Create New Design. Now you have a clean blue work plane plus a whole menu of objects you can add and customize. To add an object or shape to your work plane, simply click and drag from one of the many options on the menu on the right. You can easily change the color of the shape by clicking the colored circle above the word solid in the menu that pops up. Here you can also set dimensions using the sliders or by typing in specific measurements if you want those. Once the shape is in the work plane, you can customize it in several ways. To move it around the work plane, just click and drag. Notice how the distance measurements appear on the work plane to tell you how far away you're moving your object. To change the size of the object, click and drag on the white boxes that appear around the edges of the object. To lift the object up from the work plane, use this arrow-shaped box. You can also rotate the object easily along each axis. Notice how TinkerCad tells you how many degrees the object has turned. A big advantage of TinkerCad is that it allows you to create models in 3 dimensions. There's lots of ways to change your perspective in the work plane to see different aspects of your design. The cube in the upper left-hand corner tells you exactly what view you're currently using. By default, you have a view of the front and top. By clicking on the cube, you can jump to a view from the top, side, or bottom of your drawing. You can click and drag on the cube to get exactly the view that you want. You can also hold down the Control key, then click and drag on the work plane to rotate the whole thing. To zoom in and out, use the plus and minus buttons on the left-hand side. or you can use the same motion you use with your mouse on your trackpad to scroll up or down when reading something. The ruler tool does exactly what you expect, but it does allow you to measure the distance to the edge or to the center, the midpoint, of any object. Of course, students' products will use more than one item or material, so to add another item to the work plane, just click and drag it from the Shapes menu. Once the new piece is in the position you want, you can select all the shapes and then use the Group button at the top to link the two pieces together. Now, when one piece is moved, the other moves with it. To break them apart, just click Ungroup. Let's say you want to attach another piece at an angle. That can be done by first adding another work plane and setting it against one of the objects in the drawing. Notice how the work plane naturally creates a tangent line to the object that's already there, following the edges. Now, when I add a new item, it's oriented to the new work plane. Another creative option when grouping items is to use one shape to create a hole in another shape. This will be helpful if your drawing involves cutting objects or joining them together. To do that, when I add an object, instead of changing its color in the menu that pops up, I select Hole. Notice how the Hole option is next to the solid option with the color. Now, when I join this hole object using the Group button, a hole will be created in the object that was already in the work plane. Pretty neat. Any object can be turned into a hole. TinkerCad has many basic shapes, but if you explore the different categories in the shape menu, you'll find a lot more. The Making at Home category has many objects and materials that students will likely be using to actually build their prototypes. Here you'll find drinking straws, popsicle sticks, aluminum foil, coins, cups, containers, and much more. And if you don't see a shape you really need, you can use the Scribble option to create your own shape by drawing it freehand. Once it's in your work plane, you can modify it just like any other shape. Of course, you'll also want to add notes and labels to your drawing to explain what each piece is made of or what its purpose is. Use the Notes button on the right to add little sticky notes that you can attach to each specific object in your work plane. Then you can write a brief description in the note that will pop up whenever you click on it. Be sure to rename your project from the random name that new projects get assigned. One of the best ways to learn how to use a new tool like TinkerCad is to see what other people have already created. Then you can use and modify their ideas. The gallery is full of ideas from other users. Take a look through it if you're feeling stuck and need some inspiration. If you'd like more guidance, then click on Learn at the top right, and then you can click on Starters, or Lessons, or Projects, and there are some very specific step-by-step guides to show you some of the basics. Those are some of the basics you'll need to get started with using TinkerCad. Obviously, there is much more you can do, but with just these few tools, you'll be able to create quite a lot. If you're having trouble, the answer to your question is likely just a Google search away. Good luck and happy designing!